I'm Dave Elliott. Thanks for having me here on these Lightning Talks. I'm going to talk about machine learning for startups. And this is the Lightning Talk, so I'm going to move quickly. And at the end, I will introduce a startup that actually uses some of the software I talk about in this session. So ML for startups is the subject. And I wanted to start with really the thing that you've probably heard before that most people know. Google is an AI company. And people think of this, they think they know this based upon things like the self-driving cars that you hear so much about. But it's really Google has deployed AI across all of our products that you use today. Things like Gmail and Maps, things that you think like Photos. AI is really an integral part of what we do. Some of the high profile things you hear about with Google Research or Google Brain or DeepMind, like the AlphaGo competition, are just the tip of the iceberg. Google has deployed AI models across our entire infrastructure. So when we talk about a startup using tools or infrastructure to use AI to accelerate their success, Google has a pretty good track record. So what can machine learning do for a startup? I wanted to start with something very simple here. So the basic concept here is machine learning is using examples to make predictions. So using examples, or what we might call just simply data, to make predictions or to derive insights and predictions. And so the key questions you have to answer, and this is really machine learning 101, is what problems is your startup trying to solve? And do you have examples? Do you have data? Do you have images, or do you have conversations that build up that infrastructure of examples so that you can make predictions about what might happen and about what the right decisions to make are? So really that's the basic question. And then what I found with working with startups is, and the next couple of minutes, we'll talk about two different types of startups, two different camps, two different paths. AI foundation or foundational, where AI is in fact your differentiation, and AI as an accelerator, where really AI is just sort of the tip of the iceberg, the cherry on top of the pie, as they say. So let's split up and start with the first one, AI as a foundation. So startups, let's talk about each of these two. Startups that are AI foundational, they typically want to build the systems themselves, right? They build the systems, they develop their own models. It's really your IP. They've got expansive examples, expansive data sets, and they care a lot about community ecosystems and open source, right? We're really on the bleeding edge when it's a foundational piece of your startup. And the ability to scale, the ability to be able to do what we call machine learning operations, or ML ops, in a high volume usage, high volume scenarios, are really, really important. Meanwhile, startups that use AI as an accelerator, they're willing to leverage existing systems, existing models. They usually have limited examples. They've got maybe their own data, their own customers' data, their own customers' examples. But what's most important for them is the easy integration into their existing tools and easy access. So I would say that developers really care about, can they use, first, what do they want? They want to write great code. Can they use their existing tools and frameworks? And do people actually use their software? So really that third bullet point there on the right is the thing that I think startups care most about when they're sort of creating, using AI or machine learning as an accelerator. And the ability to obviously get started quickly. They typically don't have large data science teams. They don't even have somebody on their founding team who has a machine learning background. All right, so those are the two. Let's start with AI foundations. So AI foundations, I think when you talk about this as being AI as a differentiator, a core infrastructure, you have to start with, okay, what's the framework I'm going to use? So TensorFlow is the Google set of libraries that we open sourced a few years ago, and it has been it's created a huge ecosystem. 200 million downloads in the last 3+ years, 52 million plus tutorial and guide views, 9 million blog articles, and 10 million YouTube videos seen. And we just announced at Google I/O a couple of weeks ago that we have now over 1 million learners who've gone through Udacity or Coursera courses. So it's a huge ecosystem. And to extend on that, TensorFlow as sort of a core tenet for these companies that are using AI as a foundation, we also extended that out to the edge via TensorFlow Lite, MLKit, and TensorFlow.js, and Coral. TensorFlow Lite is an open source ML framework for on-device inference. 4 billion devices run it. MLKit, Machine Learning Kit, makes it easy for mobile developers to use on-device ML in their apps and cover sort of routine use cases, so you get started quickly. And then TensorFlow.js is machine learning for JavaScript allows developers to run machine learning in their browsers. So machine learning on the edge is a key part of an extension of TensorFlow, and really helps developers, helps startups get started quickly. The thing that I'm most excited about is Vertex AI, which is a announcement we made at Google I/O again 2 weeks ago, and it is a unified machine learning platform, and we say it's really focused on ML ops, that efficiency of building high-scale models designed for data scientists and data engineers, if you have one of those on your founding team or you've got one in your organization, so you can deploy faster and manage models with confidence. That's a little bit of marketing speak there, but let me just quickly show you one slide that might describe it. You can get models to production more quickly and manage those models. And typically, anyone who's done machine learning knows that the pipeline, the process can be 80% of the work is figuring out how to wrangle your data, how to manage your models, how to improve your models. And so across the spectrum now, Vertex AI allows your data scientist, your data science team to be able to do things like ingest your data, label your data, all the way through to deploy your models, and then manage those models, to maintain and manage those models over a period of time as you get more data, as you get more examples. So that's what Vertex AI is. Very exciting. Vertex AI is good for all levels of expertise. So I said there's these two camps, right? There's the camp of foundational folks who need efficiency and care about open source, and then there's these AI accelerators, and it's really good across all spectrums. Custom AI with AutoML in the middle here. AutoML allows you to use your own data and customize it as you're creating these models. And on the right, we talk about the end-to-end core tools, so you can use TensorFlow in the cloud. And then on the far left here, we have the pre-trained APIs. And this is the really, really, really quick jumpstart for those who are on the accelerator path, the cherry on top. That really is an easy way for developers to get started. So the lightning talk, I'm just going to quickly show you what some of those AI accelerators might be. So these are products we have really fall into 3 or 4 buckets. Perception AI is what a lot of people call it, which includes images like vision AI and video AI. It also includes perhaps a little bit of media, so you can really understand. We used to call it sight, and now it's perception. Second thing is conversational AI or conversation AI, which includes dialogue flow for chatbots. It's the #1 chatbot tool. Speech, text, translation, and natural language. And then, of course, little things like a recommendation AI. So these are all accessible easily by APIs. No data science knowledge needed, no data science, no machine learning PhDs required. These are the accelerators that quickly, when you're building your apps, you can get an app that understands what somebody's saying, understands what it sees in images and videos, and it's all accessible via easy to access APIs. So that's a whirlwind lightning talk on our portfolio and how our portfolio and how Google more broadly can help startups embrace AI, both from a foundational perspective and from an accelerated perspective. So with that, I'd like to introduce Bill Evans, CEO of a startup that serendipitously uses BigQuery, Looker, and ML in his startup, BlueZoo. BlueZoo is a startup that is looking to disrupt property insurance. And why don't I just let Bill introduce himself and his company and describe how he's using Google Cloud products. Bill?
Thanks, Dave. Great to be here. BlueZoo's mission is to use technology to make the world a safer place. We do this by measuring risk, predicting risk, and then working to prevent claims in the insurance industry. Our technology is able to anonymously detect the occupancy of a space and the presence and movement of people in that space. And as a result, insurance companies are better able to understand the characteristics of the buildings that they occupy. The goal of being able to characterize risk is to allow insurance companies to more accurately set the prices of policies to correspond to the risks presented by their customers. And in aggregate, this allows most customers to get a significant reduction in their premiums, while a handful of customers need to learn how to better reduce the risks they're presenting to insurance companies. Let me try to show this graphically. Traditionally, insurers use actuaries and actuarial models to characterize the risks presented by a group of buildings, say flower shops. Different flower shops can have different risk profiles, but because data provided to underwriters, to insurance companies, is not perfect, actuaries and underwriters need to find a model, an average that characterizes the aggregate risk for that type of business. In this particular case, looking at this chart, you can see that the risks are divided into 10 deciles, and 10% of customers in this category have very low risk, rising progressively up to some 10% of customers that have very high risk. Because traditionally insurers can't differentiate the risks at one end of the spectrum from risks at the other end of the spectrum, they set an average risk rate and everybody pays that premium. That means that the insurers effectively are making lots of money off the people with a low risk and then suffering losses for companies that have the higher risk, here shown in green and red. What instead insurers want to be able to do is they want to be able to collect enough data that they can differentiate between the people at the low end of the spectrum, the middle, and the high end of the spectrum. They want to calculate and characterize risk for each decile independently. And if they're able to do this, they can provide a fairer insurance policy rate for each of their customers. The real issue comes with how do you handle customers who have higher than average risk versus lower than average risk? Well, fundamentally, 70 or 80% of your customers are going to get lower premiums, reflecting the fact that they have less risk. 30% of your customers who have higher risk can encounter one of several outcomes. One, ideally, the insurance company is able to work with those clients to mitigate the risk. If the risk is due to overcrowding in a hotel ballroom on Thursday night, then the insurer will work with the hotel to reduce that overcrowding. If you're not able to work with a customer to mitigate risk, then as an insurer, you're going to have to either raise rates or reduce the amount of protection provided, or in the very worst case, you're going to have to decline to renew the policy. But the ambition here is to reduce the insurance gap worldwide to make insurance in aggregate cheaper for everyone. And the way to do that is to reward people, customers who have low risk, and to help mitigate the risk of those customers that today might present a higher risk. This, in the insurance industry, is called usage-based insurance, or UBI. You may know that UBI has transformed automotive insurance. In UBI, a dongle is attached to the diagnostic port of your car, and this dongle reports how you drive, how fast you accelerate, how quickly you slow down, the times of day you drive, and how far you drive. Based on this information, insurers are able to get a much better picture of the risks that you present as a client. Well, the same thing is happening in commercial property insurance. We think of ourselves at Blue Zoo as telematics, not for automobiles, but telematics for buildings. Insurers tell us that the occupancy of people correlates to risk. So if we can measure the occupancy in buildings, we can better understand how much risk people present. And again, it's critical that this information be specific to a building and not just aggregated across all buildings of a particular type, as was the case with actuarial models. And just as today insurers send risk engineers to properties to understand the details of a property, so can information about occupancy guide insurers to understand which properties are more worthy or needed, can help insurers understand which buildings should be reviewed in person by a risk analyst. And then finally, the key factor here that changes the way insurance is provided worldwide is the opportunity to mitigate risk. It's not just a matter of pricing it. If you can identify those buildings with higher risk, that small percentage that account for the largest part of risk in a cohort, then you're able to reduce risk and reduce the cost of insurance worldwide. Why is telematics for buildings relevant today? Well, the simple answer is it's relevant today because it's only been possible since a very short period of time. The biggest change that's made occupancy measurement practical is the fact that hardware and semiconductors in particularly have improved in capacity to make the cost of edge computing very low. The image you see on the right is an image of one of Google's Coral boards. So hardware innovation makes it easier both to calculate the model and possible to calculate the model at the edge. It requires very little power, but delivers tremendous performance. The second phenomenon that contributes to the perfect storm is software innovation. With the machine learning models that we use at BlueZoo, fine-grained quantized models are practical. And training a model with huge volumes of video is also practical. The cost is no longer unreasonable to bring in thousands of hours of video to train our machine learning models. And then finally, with recognition of what is personally identifiable information, BlueZoo is able to deliver products to the insurance industry that are GDPR certified. GDPR began in the European Union, but it has become a trend worldwide, and it's something that BlueZoo pays a great deal of attention to. Let me talk quickly about our architecture. We have sensors that detect the presence of movement of people on the left. These can be Wi-Fi based or optical sensors. Data from these sensors is delivered to our operational systems. The data can be delivered via Ethernet, via Wi-Fi, or via cellular backhaul. The operations system handles data in real time, and then on an hourly basis, data is offloaded, extracted, transformed, and loaded into a data warehouse. The data warehouse then serves as the primary source of data for all of our analytics tools, our web dashboards, our mobile apps, and other offline analysis. All of the fine-grained data generated by our operations system goes into the data warehouse, and we make all of this data available to our customer. Generally, we keep data at a 15-minute grain. So if you want to know the occupancy of every room in your building for the last 5 years at a 15-minute grain, you've come to the right place. And this is exactly the kind of data that insurers care about. This is a substantial technology undertaking to build this system with sensors and operations and data warehouses and visualization apps. And if we had to build all of this from the ground up, we would be truly a technology company and not an insurance solutions company. We aspire to be an insurance solutions company. So we partnered with Google to make it practical for us to focus on our value add in each of these systems and leverage Google's infrastructure to get to our end goal more quickly. Let's look again at these 4 systems that we have. Our sensors, generally very small sensors, powered by a USB port, using typically less than 5 watts. We could have built these from scratch, but it's so much more efficient to leverage Google's Coral technology and the tensor processing units that Dave described. With these tensor processing units, we're able to efficiently calculate high precision machine learning models without having to build the entire stack. Dave talked about 2 kinds of companies that embrace AI. For us, AI is foundational, and we have our PhDs in computer science and machine learning on staff to help us work with Google's tools, but their tools save us untold hours of time in product development. In the case of transaction processing, there are a variety of databases that we've had to use to build our system. The primary contribution made by Google in the cloud is for the training of our machine learning algorithms. When it comes to the third area, that is the data warehouse, most of the heavy lifting is performed by Google's BigQuery data warehouse software. Having BigQuery available to us means that we can store all of our data at the finest possible grain forever. And then finally, when it comes to visualization, as Dave mentioned, we use Looker to visualize the data managed by the BigQuery database in our data warehouse. Let me give you a quick outline of two solutions using two different sensor technologies. This slide shows our Wi-Fi sensors that passively listen for Wi-Fi signals from mobile phones. We count mobile phones as a proxy for people. The sensors collect the data, pass it to the cloud. In the cloud, we manage our data warehouse and deliver visualizations subsequently via web dashboards and mobile apps. Today, we're working on new sensors that use optical technology. The machine learning in our optical sensors will ensure that no video ever goes to the cloud. The video is processed strictly in the sensors, and occupancy counts go to the cloud, into our data warehouse, and subsequently to visualization tools. There was a joint demo that we did with Google about our use of Google machine learning technologies to develop this optical sensor, and you can see that Google I/O demo on YouTube if you search for safety and occupancy with AI. So at BlueZoo, we're committed to delivering excellent solutions, the industry's best solutions, to our insurance industry customers. Google makes it practical for us to deliver these with much less investment, much more rapidly, and with a better end result. So in summary, BlueZoo is a company dedicated to finding solutions for the insurance industry that will allow more businesses to be fully insured at lower costs by identifying risks and allowing insurers to work with customers to mitigate those risks. BlueZoo is a solutions company delivering solutions to the insurance industry, and we benefit hugely by using Google foundational components to build our products. Rather than building things from the ground up, we're able to take advantage of Google machine learning infrastructure, hardware and software, as well as Google databases like BigQuery, as well as visualization tools like Looker. And the combination of these technologies lets us focus on delivering the solutions that the insurance industry is looking for.